So in this video, we're going to write a transformed quadratic function in standard form. So instead of manipulating functions written in vertex form, we are going to focus on functions written in standard form. So just to remind you, our standard form looks a little bit different than our vertex form. So vertex form, we have the parentheses with multiple items inside of it. In standard form, everything is multiplied out and the x squareds, x's, and constant values are all combined. Something to also remember about standard form are that these a, b, and c values may have different meanings than the a, b, and c values that you see in vertex form. So a here simply stands for the coefficient of x squared, b here stands for the coefficient of x, and c here stands for your constant value that does not contain any variables attached to it. And we're going to be manipulating and transforming functions that are written in standard form instead. So we're going to take some concepts that we learned with vertex form and we're just going to summarize them here on the screen before we start working through some examples in standard form. So remember, a vertical shift is typically impacting that k value of vertex form, and essentially this is your movements up and down. So we're moving it up and down, and this is where we add or subtract to the outside of a function. So we're going to add or subtract to the outside of that entire function. A horizontal shift is just like what it sounds. It's the movements to the right and to the left. And this is where you add or subtract to the inside wherever x is. And we're going to talk about what that looks like in standard form. And remember, this is going to be the opposite of what you expect it to be. So if we're moving to the right, it will be a negative addition or a subtraction. And if we're moving to the left, it will be a positive addition. Then from here we have vertical shrinks and stretches. Remember, this is a multiplication to the outside of the entire function. So this is where we put the entire thing in parentheses and we multiply each component by that value. Then our horizontal stretches and shrinks, remember we're going to multiply the inside. So this is wherever x is, and we have to calculate our b value, which is going to be 1 over whatever our factor is, which remember is really just the reciprocal. So we can just flip that fraction right on over. Then a reflection over the x-axis, remember, is going to be a multiplication of -1 on the outside. And a reflection over the y-axis is going to be a multiplication of -1 of the inside wherever x is located. So we're going to apply these same concepts as we tackle manipulating and transforming functions written in standard form. So here we're going to transform this function here of f of x is equal to x squared minus 4x. And as I write this out now with g of x, I'm going to put parentheses around wherever x is because there's currently not any parentheses in here. So I'm going to have x squared, the x is in parentheses, then minus 4 times in parentheses x. And we'll talk about why we're doing that later, but that's going to help us as we perform these different transformations. So here it says the first thing we want to do is we want to translate this entire graph up 4 units. Remember, this is a vertical movement going up or down, and this is where we add 4 to go up to the outside. So this first translation is pretty easy. All we're going to do is we're going to add 4 to the outside. So after this particular transformation, we have g of x is equal to, and we have parentheses x squared minus 4 parentheses, and then we have the plus 4 on the outside. Now, this next one is where this gets a little bit more complicated. Here we want to translate 3 units to the right. So remember, that is a horizontal change. And then because it's to the right, which is the positive direction, we're going to subtract 3. But what's tricky about standard form is we have to subtract 3 inside of the parentheses wherever there is an x. So here we have g of x is equal to, then here we have x minus 3 quantity squared minus 4 times x minus 3 plus 4. Now, while it would be great if we could leave it in this form, we actually can't leave it in this form because we want it written in standard form to end with. So what's tricky about these standard form transformations is we have to do some math manipulation, and we have to go back to Algebra 1 to actually be able to multiply these all out. So what we're going to start with right here is we're going to multiply out whatever x minus 3 quantity squared is. And hopefully you remember from Algebra 1 that x minus 3 quantity squared is really x minus 3 times x minus 3. That's what that really represents in this problem. Now, in Algebra 1, we talked about what we are actually doing when we multiply this out, but we're taking everything in the first parenthesis and we're multiplying it by everything in the second. So I'm going to take x times x, which is x squared, x times negative 3, which is minus 3x, and then I'm taking the minus 3 times x, which is minus 3x, and times negative 3 and negative 3 is a plus 9. So if I multiply that whole piece out, I end up with x squared minus 6x plus 9. So that's this piece right here, all multiplied out and ready to be combined with everything else. Then here, I'm going to utilize keep change here really quick. And in order to simplify this one, I have to distribute that negative 4. So I end up with plus negative 4x, negative 4 times negative 3 is 12, plus 4. And then to end here, I have to combine all of my like terms. So I have g of x equals, I just see one thing with x squared. I then see minus 6x and minus 4x combined to be minus 10x. And then I see 9 plus 12 is 21, plus 4 is 25. So I multiply that all the way out, and there I have my new standard form equation where I've performed these translations up here. So you can see the process is the same, but these do get a little bit more complex, especially when it comes to the rewriting at the very, very end. All right, so let's jump in and look at this second example here. So we have, I'm going to write this with all parentheses in there. So g of x is equal to, we have 2 parentheses x squared minus 3 parentheses x plus 5. And again, we might not need this later on, but we just want to make sure we have those parentheses in there so that we know when we need to go inside or outside the parentheses. So let's start here with a vertical stretch by a factor of 2. So this is going to multiply on the outside by 2. So we're going to multiply every outside piece by 2. So that means this 2, this negative 3, and this 5. So if we multiply those all out, we end up with g of x is equal to, that becomes 4 times the x squared minus 6 times the x plus 10. Okay. Then we have a reflection about the x-axis. So that one is going to be a multiplication on the outside of negative 1. So again, we're going to multiply this outside piece by negative 1, so the 4, the negative 6, and the 10 are all multiplied by a negative 1. So now if I multiply this out, I end up with g of x is equal to negative 4 times the x squared plus 6 times the x minus 10. So then from here we move on to the horizontal shrink by a factor of 2. Remember that our b value is equal to 1 over our factor, which we know just becomes the reciprocal of 2 over 1 or 2. So we're going to multiply the inside wherever x is by 2. So here we can rewrite this as g of x is equal to negative 4, and then the 2 goes inside of here with x, plus another 2 inside of here with x, minus 10. So then we need to simplify this a little bit further. So if we take a look here, this 2x squared, if you apply the squared to that 2, this really becomes g of x is equal to 2 squared is 4, so that becomes 4, and then the x is squared. Plus, this becomes 6 times 2x, and then minus the 10. So if we then multiply these together and multiply these together, we end up with g of x is equal to a negative 16x squared plus 12x minus 10. So that does take a little bit of work when you have a horizontal stretch or shrink, especially with this first piece here where you have to square the number that is inside there with x. So last but not least, we need to take care of our translation up by a factor of 10, which really just means up 10 units. So what we're going to do is we're going to add 10 to the outside. So we're going to add 10 here to the outside and noticing that those combined to become 0. So our final function here is going to be g of x is equal to negative 16x squared plus 12x. And last but not least, let's take a look at example 3 here. So we have our child function up here that we need to transform. So I'm going to rewrite this with the parentheses in there so I know when I'm moving inside or outside the parentheses. So here I have 2, and then I have my x in parentheses squared minus 3 times my x in parentheses plus 5. So I'm going to start here by performing a vertical stretch by a factor of 3. Remember, this is a multiplication on the outside by 3. So we're going to multiply each of these terms on the outside by 3. So the 2, the negative 3, and the 5 all get multiplied by 3. So I have g of x is equal to, that becomes 6. We have x then squared minus 9 times the x plus 5. So then we're going to translate left by a factor of 2. So remember, this is going to work the opposite of what I expect. So it's going to add 2 because we're moving in the negative direction. And that's going to go inside with x. So I'm going to add 2 in here and add 2 in here. So this does become a little bit more complicated here. So here we have g of x is equal to 6 times x plus 2 all squared minus 9 times x plus 2 plus 5. So we have another situation where we're going to have to perform some more intense mathematics. So remember, order of operations, we always start with the parentheses and the exponent. So here I'm going to simplify this parenthesis with an exponent. And remember that this really means x plus 2 times itself. So it's always helpful to write that out so we can remember what we are actually multiplying. Then from here we multiply everything in the first parenthesis by everything in the second parenthesis. So we have x times x, which is x squared, x times 2, which is 2x, 2 times x, which is 2x, and 2 times 4, which is 4. Now, I do have to leave this all in parentheses for the time being because of this 6 out in front. So bear with me, we have to leave that 6 out in front there. And I'm going to also leave the 9 here and just show you how all we did was we multiplied out that squared. Then from here what we need to do is we need to distribute and combine all of the like terms that we see. So I distribute that 6. If I use keep change here, I distribute the negative 9. So here I have g of x is equal to, that's 6x squared plus we have 12x plus 12x plus 24. Then we have a negative 9x, a negative 18, and 5. So we have a number of terms that can be combined together. So first we notice that there's only one set of x squared, so we're going to leave that as is. So that becomes 6x squared. Then these 12x's combine together to become 24x, and 24x plus a negative 9x is plus 15x. And then I have 24 and a minus 18, which those become 6, and 6 plus 5 is 11. So I combined all of my like terms together, and I've now performed this translation left by a factor of 2. So you can see how the translations to the left and the right do require a little bit more work here. They're a little bit tricky, but if we just take our time and multiply it out, it's not too bad. Then the last piece here is we need to reflect in the y-axis. So remember, this is a horizontal reflection. So this is going to be a multiplication by -1 on the inside wherever x is located. So we got to add our parentheses back in here. So I'm going to add those in just around where x is. And then I'm going to multiply the x value in there by a -1. So this becomes g of x is equal to 6 times, we have a -1x squared plus 15 times a -1x plus 11. So from here, if we perform that, we have to distribute the squareds. We have a -1 squared, which becomes 1. So we just have 6 times 1x squared plus, well, 15 times a -1x becomes a -15x plus 11. So our final function here is going to be g of x is equal to 6x squared minus 15x plus 11.